In this lecture, we will learn how to design steel columns. So I'll be utilizing the same structure in which we applied all the loads including earthquake loads, gravitational loads, wind loads and seismic loads. So right now we have set the units to Newton meter. We can change the units to kilonewton meter as well. So previously we have defined the material properties already as 4000 psi for the concrete wall as well as the slab, and steel grade as 50 ksi. You can change the materials as per your requirements. So let's define some steel sections. So I'll be importing the wide flange sections for the steel beams. Since I'm using AISC 15, so I have selected the material property as 50 ksi, and for the columns I'll preferably be using W14 shapes and click on OK. And for beams I'll be using W16 shapes. You can use W12 as well, any section as per the designer's requirement. So let's assign the column sections. So I'm going to select all the columns. So these are all my columns in the structure, and click on assign frame sections, starting with W14, any section, let's say W22, and click on OK and save the model. And similarly I'll assign the beam sections. Let's go to the plan view. But if you notice, in steel structures we have the secondary beams as well. So I'll just add the secondary beams as well in the structure by using the quick draw secondary beam option. And right now we haven't defined the secondary beams, so I'll define the secondary beams first. Number of beams, let's make them 2. I have clicked on show analysis model so I can see if my secondary added beam is exactly meshing the slab node. Let's hide the I have selected this beam and hide it. Yes, it was exactly meshing my slab, so it is okay. If was not meshing my slab, then I'll have to manually mesh the slab, as we have discussed in detail how to mesh the slab. So my beam is actually transferring the forces correctly, and the slab is also transferring the forces correctly. So I have assigned the beams, columns and secondary beams to the structure. Now next step is to go to design steel frame design. Since we are interested in steel frame design, so I'll select the steel frames only, which is, I'll go to the plan view, select the steel beams. Let's hide the area options and joints and go to 3D view. So now I have all the cell members visible that are the steel structures only. Let's hide the grids as well for time being. So this is my steel structure. I'll select all these members and go to design, override frame design procedure and click on default from material, which will automatically be selecting the steel design procedure. And now select the members, go to design, steel frame design, view, revise, overrides. Here you can see the framing type as SMF, IMF, OMF depending upon your code criteria. Since we are using the intermediate moment resisting frame based on the code criteria according to the seismic load and the acceleration values, I am utilizing intermediate moment resisting frame. This is a theoretical background which you can always find in the code AISC 36016, but the purpose of this course is how to implement the changes and calculations in SAP 2000. So I have shown you how we can change the code criteria from here. You can also see all the variables and you can change them from here, including deflection limits, camber limits, live load limit, absolute, measure and bridge length, LTB and bridge length, and so on. Also go to design, steel frame design, view, revise, preferences. We have selected SMF here, so I'll change it to IMF. The design code is AISC 360 and the case response is envelopes. You have to note that the blue values are the default values, black value are not default, and the red value that has just changed right now. So if I click on OK and go back again, the previous change becomes black. The red, if I change any new thing, it would become red right now, and when I open it again, it would become black. So we have to manage these values: default system, SDS, R, omega, and CD. This would come from the earthquake load case. So go to define load patterns, earthquake in X direction. So let's take a screenshot of this window. Go to design, steel frame design, and let's open our screenshot here. Okay, so my R value and omega and all these values are given here: R 7, 2.5 and 5.5, and the design provision is LRFD, and the values other than this one, that is design system seismic design category, you can always find it from the code or you can change it from the value as per the code criteria AISC 360. And you can change the design system SDS. The SDS value for us is 0.9. This will be important in the automatic load combination generation, and click on OK. Now go to define load combinations, add default design combination, steel frame design, and click on OK. So these are the default design combinations. You can always modify these combinations as well. These are the design combinations default added. Now go to design, steel frame design, select design combinations. It automatically has taken the design combinations in and out for itself, and you can always go to here. Or if you have manually added your combinations, you can uncheck this option. But since we are using the automatically generated code based load combinations based on the design system SDS that we selected as point 0.9, so we have to check this option and click on OK. You can also change the deflection load combination it will use to check the design for serviceability and click on OK. Now perform the analysis for the structure. And then click on steel frame design. Since our focus for this tutorial is to design steel columns only, so we'll be ignoring any failures coming in the beams. We'll only be focusing on the columns. So first let's turn off the visibility of the beams. Now you can easily see from this scale, this is the stress ratio graph. The cyan color means the stress ratio in the member is less than 50%, and the green color shows the stress ratio is more than 50% but less than 70%, and yellow color shows more than 70 and less than 90%, while orange color and red color comes in the danger zone. Stress in red color shows failure. So you can right click on any of the red colored member and check the failure. So it is failing in the combination DSTL99, and the combination mode is, it is showing C, that is the compression, axial, major moment, minor moment. You can also see the details from here. Section is overstressed because of the KL over R value. You can change the units from here, as well as you can all see the values of the moments as well as the design forces from here. The axial forces, major minor moment, shear check as well. So you can override the property of the design section. Let's say my design section was W1422. If I make it a little heavier section, W1426, so it is still not passing. So let's change the section once again. It's near to being passed. Now the stress is less than 100%, and it is 86.5%, so the section has passed. Similarly, what we can do is we can unlock the model. In spite of checking all the structure members once again, I will select the lower level columns and assign them the bigger section that was passing. That was W14 by 34. Check the 3D view and perform the analysis once again. I have selected these columns and click on design option. The columns are still failing. The reason for the failure is when the analysis is complete, it redistributes the forces according to the stiffness. So the override option, whenever you pass a column in the from the override option, You have to assign the section once again by unlocking the model and then run the analysis once again, just like I did. So if another section is passing, let's say 34 is failing, so let's select W14 by 43 and it is passing here, but we have to recheck it by unlocking the model and assigning it so that the analysis is also carried out according to the new section. Right now it was still performing the analysis according to the old section, but the only design forces were kept same while the design section properties were changed. So we have to do this again and again as the design is an iterative procedure. Now let's see if this section passes the check. So we have still few failures. Let's see. So it is 1.1%. I'm going to see the stress ratio from outside. So it is now showing the stress ratio. I check the stress ratio from here. Click on display design info. You can check different ratios as well. PMM interaction ratios show value above as well as design input sections. But right now we are interested in design output or identify all failures, maximum stress ratios. We have to revise the sections once again. Let's see. So now still the failure is in the maximum load is in the maximum value in the interaction equation is in axial force as well as the minor moment. For finding out how to pass the minor moment, I have to see another thing. Let's click on undeformed shape. Now you have to see the extruded view. So the extruded view shows that my column's stronger side is this direction as well as we have a shear wall in this direction of the building. What if we rotate the columns and see the design? I'm selecting all the columns and now I'll rotate them. It would be easier if I form a column group so that I don't have to select them individually. Let's rotate the columns. As we have the shear wall as well as the columns strong dimension aligned to in the same direction and we have to strengthen the y direction. So we'll use the columns to strengthen the y direction. Make this 90 degrees. Now I'm going to remove the extruded view and once again select the columns and click on design. So now you see I'm using the same column sections and the structure is passing the stress check. We can also see the different modes of analysis. So the maximum stress ratio is coming out to be 96.2%. We can see different outputs from here. PMM interaction ratios. Identify all failures as well. And here we can see all the failure modes. So this one and this one is failing in flexure because of the reason it is exceeding the 95% value. Although 100% value is okay. If you can see view revise preferences, we have specified the limit as 95%. We can keep it as 1 as well and click on OK and it will pass the design. Let's design it once again and it will not show failure this time. The software keeps a factor of safety in and of itself. So what I'm going to do is I'm going to identify all the failures once again. So you see it is not failing this time. However, it is also always better to keep the stress ratio restricted to 95% and you can increase the section size. I have set the limit back to 95%. I have set the limit back to and I am checking the failure mode once again. So this is showing flexure and this is showing flexure. So I am going to change their section size to the next larger size, 14 by 48. Now it is passed, and similarly for this one. One last thing left is that I have to unlock the model and override them from outside, which the software automatically doesn't. So this is one of the most important steps. You can also check the section. Run the analysis once again. The software automatically generated a lot of wind load cases because of the constraints we added, and it is a normal thing because we have defined the automatic wind load. Let's design the columns and identify the failures once again and see whether we need to increase the column size this time or not. So there is no failure this time. So we are okay with the design of the columns. That is how we design simple steel columns in SAP 2000.